Chapter 10 of The Story of Alchemy. This LibriVox recording is in the public domain. Recording by Peter Yearsley. The Story of Alchemy and the Beginnings of Chemistry by M. M. Pattison Muir. Chapter 10. Summary of the alchemical doctrine. The replacement of the three principles of the alchemists by the single principle of phlogiston. The sacred art, which had its origin and home in Egypt, was very definitely associated with the religious rites and the theological teaching recognized by the state. The Egyptian priests were initiated into the mysteries of the divine art, and as the initiated claimed to imitate the work of the deity, the priest was regarded by the ordinary people as something more than a representative, as a mirror of the divinity. The sacred art of Egypt was transmuted into alchemy by contact with Egyptian thought and handicrafts, and the tenets and mysticism of the Catholic Church, and the conception of nature which was the result of this blending prevailed from about the 9th until towards the end of the 18th century. Like its predecessor, alchemy postulated an orderly universe, but alchemy was richer in fantastic details, more picturesquely embroidered, more prodigal of strange fancies than the sacred art of Egypt. The alchemist constructed his ordered scheme of nature on the basis of the supposed universality of life. For him everything lived, and the life of things was threefold. The alchemist thought he recognized the manifestation of life in the form or body of a thing, in its soul, and in its spirit. Things might differ much in appearance, in size, taste, smell, and other outward properties, and yet be intimately related, because, according to the alchemist, they were produced from the same principles, they were animated by the same soul. Things might resemble one another closely in their outward properties, and yet differ widely in essential features, because, according to the alchemist, they were formed from different elements. In their spiritual properties they were unlike. The alchemists taught that the true transformation, in alchemical language the transmutation, of one thing into another could be effected only by spiritual means acting on the spirit of the thing, because the transmutation consisted essentially in raising the substance to the highest perfection whereof it was capable. The result of this spiritual action might become apparent in the material form of the substance. In attempting to apply such vague conceptions as these, alchemy was obliged to use the language which had been developed for the expression of human emotions and desires, not only for the explanation of the facts it observed, but also for the bare recital of these facts. The outlook of alchemy on the world outside human beings was essentially anthropomorphic. In the image of man the alchemist created his universe. In the times when alchemy was dominant, the divine scheme of creation, and the place given to man in that scheme, were supposed to be thoroughly understood. Everything had its place, designed for it from the beginning, and in that place it remained, unless it were forced from it by violent means. A great part of the business of experimental alchemy was to discover the natural position or condition of each substance, and the discovery was to be made by interpreting the facts brought to light by observation and experiment, by the aid of hypotheses deduced from the general scheme of things which had been formed independently of observation or experiment. Alchemy was a part of magic, for magic interprets and corrects the knowledge gained by the senses, by the touchstone of generalizations which have been supplied partly by the emotions and partly by extra-human authority, and accepted as necessarily true. The conception of natural order, which regulates the life of the savage, is closely related to that which guided the alchemists. The essential features of both are the notion that everything is alive, and the persuasion that things can be radically acted on only by using life as a factor. There is also an intimate connection between alchemy and witchcraft. Witches were people who were supposed to make an unlawful use of the powers of life. Alchemists were often thought to pass beyond what is permitted to the creature, and to encroach on the prerogative of the Creator. The long duration of alchemy shows that it appealed to some deep-seated want of human beings. Was not that want the necessity for the realization of order in the universe? Men were unwilling to wait until patient examination of the facts of their own nature and the facts of nature outside themselves might lead them to the realization of the interdependence of all things. They found it easier to evolve a scheme of things from a superficial glance at themselves and their surroundings, Naturally they adopted the easier plan. Alchemy was a part of the plan of nature produced by this method. The extraordinary dominancy of such a scheme is testified to by the continued belief in alchemy, although the one experiment, which seems to us to be the crucial experiment of the system, was never accomplished. But it is also to be remembered that the alchemists were acquainted with and practised many processes which we should now describe as operations of manufacturing and technical chemistry, and the practical usefulness of these processes bore testimony, of the kind which convinces the plain man, to the justness of their theories. I have always regarded two facts as most interesting and instructive: that the doctrine of the essential unity of all things, and the simplicity of natural order, was accepted for centuries by many, I think one may say by most men, as undoubtedly a true presentation of the divine scheme of things; and secondly, that in more recent times people were quite as certain of the necessary truth of the doctrine, the exact opposite of the alchemical, that the Creator had divided his creation into portions, each of which was independent of all the others. Both of these schemes were formed by the same method, by introspection preceding observation. Both were overthrown by the same method, by observation and experiment proceeding hand in hand with reasoning. In each case the humility of science vanquished the conceit of ignorance. The change from alchemy to chemistry is an admirable example of the change from a theory formed by looking inwards, and then projected on to external facts, to a theory formed by studying facts, and then thinking about them. This change proceeded slowly. It is not possible to name a time when it may be said, here alchemy finishes and chemistry begins. To adapt a saying of one of the alchemists, quoted in a former chapter, alchemy would not easily give up its nature, and fought for its life, but an agent was found strong enough to overcome and kill it, and then that agent also had the power to change the lifeless remains into a new and pure body. The agent was the accurate and imaginative investigation of facts. The first great step taken in the path which led from alchemy to chemistry was the substitution of one principle, the principle of phlogiston, for the three principles of salt, sulphur, and mercury. This step was taken by concentrating attention and investigation, by replacing the superficial examination of many diverse phenomena by the more searching study of one class of occurrences. That the field of study should be widened, it was necessary that it should first be narrowed. Lead, tin, iron, or copper is calcined. The prominent and striking feature of these events is the disappearance of the metal, and the formation of something very unlike it. But the original metal is restored by a second process, which is like the first, because it also is a calcination, but seems to differ from the first operation in that the burnt metal is calcined with another substance, with grains of wheat or powdered charcoal. Led thereto by their theory that destruction must precede revivification, death must come before resurrection, the alchemists confined their attention to one feature common to all calcinations of metals, and gave a superficial description of these occurrences by classing them together as processes of mortification. Sulphur, wood, wax, oil, and many other things are easily burned. The alchemists said these things also undergo mortification, they too are killed, but as man can restore that which man has destroyed, it must be possible to restore to life the thing which has been mortified. The burnt sulphur, wood, wax, or oil is not really dead, the alchemists argued. To use the allegory of Paracelsus, they are like young lions which are born dead, and are brought to life by the roaring of their parents. If we make a sufficiently loud noise, if we use the proper means, we shall bring life into what seems to be dead material, as it is the roaring of the parents of the young lions which alone can cause the stillborn cubs to live. So it is only by the spiritual agency of life, proceeded the alchemical argument, that life can be brought into the mortified sulphur, wood, wax, and oil. The alchemical explanation was superficial, theoretical in the wrong meaning of that word, and unworkable. It was superficial because it overlooked the fact that the primary calcination, the mortification, of the metals and the other substances was effected in the air, that is to say, in contact with something different from the thing which was calcined. The explanation was of the kind which people call theoretical, when they wished to condemn an explanation and put it out of court, because it was merely a restatement of the facts in the language of a theory which had not been deduced from the facts themselves, or from facts like those to be explained, but from what were supposed to be facts without proper investigation, and if facts were of a totally different kind from those to which the explanation applied. And lastly, the explanation was unworkable because it suggested no method whereby its accuracy could be tested, no definite line of investigation which might be pursued. That great naturalist, the Honourable Robert Boyle, born in 1626, died in 1691, very perseveringly besought those who examined processes of calcination to pay heed to the action of everything which might take part in the processes. He was especially desirous that they should consider what part the air might play in calcinations. He spoke of the air as a menstruum or additament, and said that in such operations as calcination we may well take the freedom to examine whether there intervene not a coalition of the parts of the body wrought upon with those of the menstruum, whereby the produced concrete may be judged to result from the union of both. It was by examining the part played by the air in processes of calcination and burning that men at last became able to give approximately complete descriptions of these processes. Boyle recognized that the air is not a simple or elementary substance. He spoke of it as a confused aggregate of effluviums from such differing bodies, that though they all agree in constituting by their minuteness and various motions one great mass of fluid matter, yet perhaps there is scarce a more heterogeneous body in the world. Clement of Alexandria, who lived in the end of the 2nd and the early part of the 3rd century A.D., seems to have regarded the air as playing a very important part in combustions. He said, "Airs are divided into two categories, an air for the divine flame, which is the soul, and a material air, which is the nourisher of sensible fire and the basis of combustible matter." Sentences like that I have just quoted are found here and there in the writings of the earlier and later alchemists. Now and again we also find statements which may be interpreted, in the light of the fuller knowledge we now have, as indicating at least suspicions that the atmosphere is a mixture of different kinds of air, and that only some of these take part in calcining and burning operations. Those suspicions were confirmed by experiments on the calcination of metals and other substances, conducted in the 17th century by Jean Rey, a French physician, and by John Mayo of Oxford. But these observations, and the conclusions founded on them, did not bear much fruit until the time of Lavoisier, that is, towards the close of the 18th century. They were overshadowed and put aside by the work of Stahl, 1660 to 1724. Some of the alchemists of the 14th, 15th, and 16th centuries taught that combustion and calcination are processes wherein the igneous principle is destroyed, using the word destroyed in its alchemical meaning. This description of processes of burning was much more in keeping with the ideas of the time than that given by Boyle, Rey, and Mayo. It was adopted by Stahl, and made the basis of a general theory of those changes wherein one substance disappears, and another or others very unlike it are produced. That he might bring into one point of view and compare the various changes effected by the agency of fire, Stahl invented a new principle which he named phlogiston, and constructed an hypothesis which is generally known as the phlogistic theory. He explained and applied this hypothesis in various books, especially in one published at Halle in 1717. Stahl observed that many substances which differed much from one another in various aspects were alike in one respect: they were all combustible. All the combustible substances, he argued, must contain a common principle. He named this supposed principle phlogiston, from the Greek word phlogistos, meaning burnt or set on fire. Stahl said that the phlogiston of a combustible thing escapes as the substance burns, and, becoming apparent to the senses, is named fire or flame. The phlogiston in a combustible substance was supposed to be so intimately associated with something else that our senses cannot perceive it. Nevertheless, the theory said, it is there. We can see only the escaping phlogiston. We can perceive only the phlogiston which is set free from its combination with other things. The theory thought of phlogiston as imprisoned in the thing which can be burnt, and as itself forming part of the prison, that the prisoner should be set free, the walls of the prison had to be removed. The freeing of the prisoner destroyed the prison. As escaping or free phlogiston was called fire or flame, so the phlogiston in a combustible substance was sometimes called combined fire, or flame in the state of combination. A peculiarity of the strange thing called phlogiston was that it preferred to be concealed in something, hidden, imprisoned, combined. Free phlogiston was supposed to be always ready to become combined phlogiston. The phlogistic theory said that what remains when a substance has been burnt is the original substance deprived of phlogiston, and therefore to restore the phlogiston to the product of burning is to reform the combustible substance. But how is such a restoration of phlogiston to be accomplished? Evidently by heating the burnt thing with something which is very ready to burn, because, according to the theory, everything which can be burnt contains phlogiston. The more ready a substance is to burn, the richer it is in phlogiston. Burning is the outrush of phlogiston. Phlogiston prefers to be combined with something. Therefore, if you mix what remains after burning with something which is very combustible, and heat the mixture, you are bringing the burnt matter under conditions which are very favourable for the reception of phlogiston by it, for you are bringing it into intimate contact with something from which freedom-hating phlogiston is being forced to escape. Charcoal, sulphur, phosphorus, oils, and fats are easily burnt. These substances were therefore chosen for the purpose of changing things which had been burnt into things which could again be burnt. These and a few other substances like these were classed together and called phlogisticating agents. Very many of the substances which were dealt with by the experimenters of the last quarter of the 17th and the first half of the 18th century were either substances which could be burned, or those which had been produced by burning. Hence the phlogistic theory brought into one point of view, compared, and emphasized the similarities between a great many things which had not been thought of as connected before that theory was promulgated. Moreover, the theory asserted that all combustible or incinerable things are composed of phlogiston and another principle, or, as was often said, another element, which is different in different kinds of combustible substances. The metals, for instance, were said to be composed of phlogiston and an earthy principle or element, which was somewhat different in different metals. The phlogistians taught that the earthy principle of a metal remains in the form of ash, cinders, or calx, when the metal is calcined, or, as they expressed it, when the metal is deprived of its phlogiston. The phlogistic theory savoured of alchemy. It postulated an undefined, undefinable, intangible principle. It said that all combustible substances are formed by the union of this principle with another, which is sometimes of an earthy character, sometimes of a fatty nature, sometimes highly volatile in habit. Nevertheless, the theory of Stahl was a step away from purely alchemical conceptions towards the accurate description of a very important class of changes. The principle of phlogiston could be recognized by the senses as it was in the act of escaping from a substance, and the other principle of combustible things was scarcely a principle in the alchemical sense, for in the case of metals, at any rate, it remained when the things which had contained it were burnt, and could be seen, handled, and weighed. To say that metals are composed of phlogiston and an earthy substance was to express facts in such a language that the expression might be made the basis of experimental inquiry. It was very different from the assertion that metals are produced by the spiritual actions of the three principles, salt, mercury, and sulphur, the first of which is not salt, the second is not mercury, and the third is not sulphur. The followers of Stahl often spoke of metals as composed of phlogiston and an element of an earthy character. This expression was also an advance from the hazy notion of element in purely alchemical writings towards accuracy and fullness of description. An element was now something which could be seen and experimented with. It was no longer a semi-spiritual existence which could not be grasped by the senses. The phlogistic theory regarded the calcination of a metal as the separation of it into two things unlike the metal, and unlike each other. One of these things was phlogiston, the other was an earth-like residue. The theory thought of the reformation of a metal from its calx, that is, the earthy substance which remains after combustion, as the combination of two things to produce one apparently homogeneous substance. Metals appeared to the phlogisteans, as they appeared to the alchemists, to be composite substances. Processes of burning were regarded by alchemists and phlogisteans alike as processes of simplification. The fact had been noticed and recorded during the Middle Ages that the earth-like matter which remains when a metal is calcined is heavier than the metal itself. From this fact, modern investigators of natural phenomena would draw the conclusion that calcination of a metal is an addition of something to the metal, not a separation of the metal into different things. It seems impossible to us that a substance should be separated into portions, and one of these parts should weigh as much as or more than the whole. The exact investigation of material changes, called chemistry, rests on the statement that mass, and mass is practically measured by weight, is the one property of what we call matter, the determination whereof enables us to decide whether a change is a combination or coalescence of different things, or a separation of one thing into parts. That any part of a material system can be removed without the weight of the portion which remains being less than the original weight of the whole system is unthinkable in the present state of our knowledge of material changes. But in the 17th century, and throughout most of the 18th, only a few of those who examined changes in the properties of substances paid heed to changes of weight. They had not realized the importance of the property of mass as measured by weight. The convinced upholder of the phlogistic theory had two answers to the argument that because the earth-like product of the calcination of a metal weighs more than the metal itself, therefore the metal cannot have lost something in the process. For if one portion of what is taken away weighs more than the metal from which it has been separated, it is evident that the weight of the two portions into which the metal is said to have been divided must be considerably greater than the weight of the undivided metal. The upholders of the theory sometimes met the argument by saying, of course the calx weighs more than the metal, because phlogiston tends to lighten a body which contains it, and therefore the body weighs more after it has lost phlogiston than it did when the phlogiston formed part of it. Sometimes, and more often, their answer was, loss or gain of weight is an accident, the essential thing is change of qualities. If the argument against the separation of a metal into two constituents by calcination were answered today as it was answered by the upholders of the phlogistic theory in the middle of the 18th century, the answers would justly be considered inconsequent and ridiculous, but it does not follow that the statements were either far-fetched or absurd at the time they were made. They were expressed in the phraseology of the time, a phraseology, it is true, sadly lacking in consistency, clearness, and appropriateness, but the only language then available for the description of such changes as those which happen when metals are calcined. One might suppose that it must always have sounded ridiculous to say that the weight of a thing can be decreased by adding something to it, that part of a thing weighs more than the whole of it, but the absurdity disappears if it can be admitted that mass, which is measured by weight, may be a property like colour or taste or smell, for the colour, taste, or smell of a thing may certainly be made less by adding something else, and the colour, taste, or smell of a thing may also be increased by adding something else. If we did not know that what we call quantity of substance is measured by the property named mass, we might very well accept the proposition that the entrance of phlogiston into a substance decreases the quantity, hence the mass, and therefore the weight of the substance. Although Stahl and his followers were emerging from the trammels of alchemy, they were still bound by many of the conceptions of that scheme of nature. We have learned in previous chapters that the central idea of alchemy was expressed in the saying, matter must be deprived of its properties in order to draw out its soul. The properties of substances are everything to the modern chemist. Indeed, such words as iron, copper, water, and gold are, to him, merely convenient expressions for certain definable groups of properties. But the phlogisteans regarded the properties of things, including mass, as of secondary importance. They were still trying to get beneath the properties of a thing to its hypothetical essence or substance. Looking back, we cannot think of phlogiston as a substance or as a thing in the modern meanings of these terms as they are used in natural science. Nowadays we are obliged to think, of the sum of the quantities of all the things in the universe as unchanging, and unchangeable by any agency whereof we have definite knowledge. The meaning we give to the word thing rests upon the acceptance of this hypothesis. But the terms substance, thing, properties were used very vaguely a couple of centuries ago, and it would be truly absurd to carry back to that time the meanings which we give to these terms today, and then to brand as ridiculous the attempts of the men who studied then the same problems which we study now, to express the results of their study in generalizations which employed the terms in question in what seems to us a loose, vague, and inexact manner. By asserting, and to some extent experimentally proving, the existence of one principle in many apparently very different substances, or, as would be said today, one property common to many substances, the phlogistic theory acted as a very useful means for collecting and placing in a favourable position for closer inspection many substances which would probably have remained scattered and detached from one another had this theory not been constructed. A single assumption was made, that all combustible substances are alike in one respect, namely in containing combined fire, or phlogiston. By the help of this assumption, the theory of phlogiston emphasised the fundamental similarity between all processes of combustion. The theory of phlogiston was extraordinarily simple, compared with the alchemical vagaries which preceded it. Hoefer says in his Histoire de la Chimie, "If it is true that simplicity is the distinctive character of verity, never was a theory so true as that of Stahl." The phlogistic theory did more than serve as a means for bringing together many apparently disconnected facts. By concentrating the attention of the students of material changes on one class of events, and giving descriptions of these events without using either of the four alchemical elements, or the three principles, Stahl, and those who followed him, did an immense service to the advancement of clear thinking about natural occurrences. The principle of phlogiston was more tangible and more readily used than the salt, sulphur, and mercury of the alchemists; and to accustom people to speak of the material substance which remained when a metal or other combustible substance was calcined or burnt, as one of the elements of the thing which had been changed, prepared the way for the chemical conception of an element as a definite substance with certain definite properties. In addition to these advantages, the phlogistic theory was based on experiments, and led to experiments, the results of which proved that the capacity to undergo combustion might be conveyed to an incombustible substance, by causing it to react with some other substance itself combustible under definite conditions. The theory thus prepared the way for the representation of a chemical change as an interaction between definite kinds of substances, marked by precise alterations both of properties and composition. The great fault of the theory of phlogiston, considered as a general conception which brings many facts into one point of view, and leads the way to new and exact knowledge, was its looseness, its flexibility. It was very easy to make use of the theory in a broad and general way. By stretching it here and modifying it there, it seemed to cover all the facts concerning combustion and calcination which were discovered during 2 generations after the publication of Stahl's books. But many of the subsidiary hypotheses which were required to make the theory cover the new facts were contradictory, or at any rate seemed to be contradictory, of the primary assumptions of the theory. The addition of this ancillary machinery burdened the mechanism of the theory, threw it out of order, and finally made it unworkable. The phlogistic theory was destroyed by its own cumbersomeness. A scientific theory never lasts long if its fundamental assumptions are stated so loosely that they may be easily modified, expanded, contracted, and adjusted to meet the requirements of newly discovered facts. It is true that the theories which have been of the greatest service in science, as summaries of the relations between established facts, and suggestions of lines of investigation, have been stated in terms whose full meaning has gradually unfolded itself. But the foundations of these theories have been at once so rigidly defined and clearly stated as to be incapable of essential modification, and so full of meaning and widely applicable as to cover large classes of facts which were unknown when the theories were constructed. Of the founders of the lasting and expansible theories of natural science, it may be said that thoughts beyond their thoughts to those high bards were given. Chapter 11.